What's up, class? This is chapter 2-3, linear functions in slope-intercept form. It's good stuff here. So let's go over some ideas in the notes. Vocabulary. Circle the relation that is also a function. We have 0, 1, negative 1, 3, and 0, 4. 2, 5, 3, 3, 4, 1. Negative 2, 3, and 4, 7. You have 0 down here. So you're going to circle this one as also a function. Biggest thing is here you have, and let's highlight this so you can see it better. Here's a yellow one if this works. You have repetition. That cannot happen. We know that. And also here, repetition. That cannot happen. The x cannot repeat itself. So the only one that is a function is this one right here. Here's our definitions real quick. We've learned this for many, many years. Slope equals rise over run. We've also learned, and it's on the board every day in class, that slope is your m. That equals slope. We've also learned that slope is y2 minus y1 over x2 minus x1. And you divide that, and you should equal your m, or slope. You want to keep it in fraction form though still. So basically it's a change in vertical over the change in horizontal. And that equals that. Slope describes the steepness of a line in the coordinate plane. So steepness. Or if it's negative, the lack of steepness. The slope of a hill is its steepness. It's an example. So here we go. Use the graph at the right. Draw a line from the slope in column A to line with the slope in column B. Okay, here is D. D is going downhill. That's negative. So let's go find D and let's go to negative. Boom. Let's do this guy now. This is A. This is straight up. It's positive. So A is positive. It's going to go straight across. Then this one is B is straight across. So no slope, right? B is no slope or 0 slope. Then when it's straight down, we watch that slope man video, is undefined, and that is slope C. So that's our notes right there. We'll go to page 35 and talk about more notes. Here's what we were just talking about before. The slope of a non-vertical line is the ratio of vertical change to a corresponding horizontal change. Slope equals vertical change, rise, divided by horizontal change, run. Or y2 minus y1, x2 minus x1. Any questions? Mr. Weckeser is in the front of class. He can help you right now. 3 and 4. Their answers are going to be positive and negative. And over here, we have the numbers. Y1 is 4 and Y2 is 1. We get those numbers from right here. Y1, it's the first Y coordinate, and the second Y coordinate is right here. So again, complete the model below. Slope equals vertical change over horizontal change. And over is a better word than divided by. It's not really dividing. We're going to keep it over as a fraction form. And y2 minus y1 over x2 minus x1. And then we're going to put down the numbers here. Here's 1 that we said before. It's y2. 4 is y1. Then we have x2 and x1. So we have 8 and 5 here. So, and this is kind of a funky thing because you need to show the next step. 1 minus 4 is actually equal to negative 3. And then 8 minus 5 is 3. And so your slope is negative 3 over 3 or negative 1 over 1, or you can write it negative 1. So the slope of the line through the points 5, 4 and 8, 1 is repetitive from there is negative 1. Now we're going to label these right here. And this is what we did in class the other day. I know it's repetitive. This is a 0 slope. Straight across. Undefined is straight down. Straight diagonally and going up any direction from left to right is going to be a positive slope. And going down from left to right is going to be a negative slope. A line that has a 0 slope is horizontal. And a line that is undefined is going to be what? That's going to be vertical, straight up. Undefined looks like this. 0 looks like this. Here is the key concept, slope-intercept form. Slope-intercept form is y equals mx plus b. And we discussed this many times in class, many years before, and you're learning how to graph a line. M is the slope, and 0b is the y-intercept. So there's your slope. Here's your y-intercept. So place a check in the box that is in slope-intercept form. Check. This is not. I'm not sure what kind of form that is. And then y equals x is in slope-intercept form. It's just missing the y-intercept, which could be a plus 0 here. The y-intercept, oh, here we go. The slope of the line with the equation y equals 4x plus 2 is 4. That's the slope right here. The y-intercept, it's always the last number by itself, 0, negative 3. Circle the graph that can be represented by the equation y equals negative 2x plus 3. We're going to circle this guy, and here's a couple reasons. It's a negative slope. This is not negative, this is positive. Again, this is positive. It could be this one or this one. This is going downhill, this is going downhill. This one, the y-intercept is at plus 3 between the 1 and 2, or yeah, between here and here. 2 and 4. This one is negative 3, so this one can't be right. So it's got to be this one. Linear equations. Please write a phrase to describe each constant value. M is the slope. I'm not going to write the whole phrase, just write slope. And B is the y coordinates. The equation of the line and the slope of the form is, we're using these up here by the way, y equals 6x, and then here's the 0, 5, so it's going to be plus 5. Then we have problem 3, and we're going to stop there today after problem 3. Use the equation 3x plus 2y equals 18. In slope-intercept form, what are the slope and y-intercepts? So first we need to solve it. This is standard form. We need to get it in y-intercept form. So the first thing to do is subtract 3x from each side. And then you get 18 minus 3x. You have divide by 2, right? So 9, y equals 9 minus 3 over 2x. And the slope in the equation should be negative 3 over 2. Slope, negative 3 over 2. The y-intercept is going to be this 9 guy right here. And that's it for today. You're going to then go and skip number 4. We don't need to do that one. You do lesson check. And do the lesson check and turn it into Mr. Weckeser and get points for lesson check. Thank you. Have a good day.